Today we're going to look at inverse functions, and I suppose by now you've understood the lessons which came before this one in terms of what functions are. I would like you to play that video and recall the functions and where they are set up and the meaning of the notation fx. Now today we're going to look at the inverse function. The inverse function will become very clear to you as I go on the board. But I want you to think of the inverse function as the opposite, or something which undoes what was done. And follow me now at the board. I'm going to explain a bit of stuff here. An inverse function. So inverse functions. Suppose fx is equal to 2x plus 6 the inverse function, okay, in this presentation we are looking at fx is equal to 2x minus 2x plus 6. That is our inverse. 2x plus 6. So the inverse function f is our normal function and written as f minus 1 is the inverse function. So it means the opposite, right? The opposite of f. That is the notation. The opposite of f. So in a way, we are looking for fx. Can you see the way it's written? We are looking for fx. So now let's read back our initial, let's call it 1. fx means 2x plus 6. 2 times x plus 6. So the opposite inverse function, or should read, ideally should read x take away 6 divided by 2. That is the inverse, but you're confused a little bit. How did this happen? Okay, how did this happen? The best way to write an inverse function, let me take you back to fx, which is simply 2x plus 6. Now remember, we said fx actually represents y, so we can rewrite this one as that. Now to get the inverse of this function, what we simply do is, as looking for, to make x the subject of the formula that is going to give us the inverse. So our goal now is to make x the subject of the formula. Which formula? The initial function fx is equal to 2x plus 6. Now we want to make x the subject of the formula. That's how we get the inverse. How does that work? Okay, so we have y is equal to 2x plus 6. To make x the subject of the formula, what we do, we subtract both sides. We subtract both sides by 6. So what happens? The easiest way is you circle that one, bring it over the other side, and once it jumps the equal sign, it becomes minus. So we have y minus 6 is equal to 2x. Can you see that? Now we still have x over here. We want to change that one. We want to change that y minus 6 divided by 2 is equal to x. In terms of functions, you just simply say inverse fx is equal to y minus 6 over 2. That is your opposite. You got it right. You got it right. That's your opposite. You got it right. Now once you have the equation as written, the function as the inverse function as written f minus 1 on the top, x in the brackets is equal to y minus 6 over 2. That is the way it looks like at the moment. But now the final stage will be you must replace x in every position you see y. So in this case, we have to now change to the concluding inverse function, which will look as follows. And I'll go to the board for you and change it. That's the final stage. And the final stage, I'll put it in blue. We say replace y for x. Now you have f inverse x is equal to x minus 6 over 2. And this is now your final answer. Now that is the final answer for the inverse function. Now we are going to look at a little bit more problems in this mathematics textbook. So we have gone through how actually you arrive at the inverse function. Let us have some more examples. This is find f inverse for the following. Okay? Find these ones. Let's see. Let's see. Number 1, f x equals x plus 7. Very quickly, this becomes your y, making x the subject of the formula. We have y minus 7 is equal to x. So y minus 7 is equal to x. So you're going to say the f x is equal to y minus 7. So replace for x that is your inverse. Think of y is equal to 8 x, make x the subject of the formula. You divide through by 8, you have x. Now make the replacements. Y over 8, you have x over 8. So your final inverse function is fx inverse is equal to 8 over 8. Another example. Example 3. Let's use fx, okay, is equal to 2 over x plus 1. Remember the rule, always make this into y, fx into y, then you have x plus 1. Your mission is to make x the subject of the formula. With this type of questions, imagine you have y over 1 is equal to 2 over x plus 1. What are you going to do? Cross multiply. Okay, cross multiply. This times that, so we have y bracket x plus y is equal to that times that, that times that. So we've got 2 over here. We are trying to make x the subject of the formula. So we multiply through. We have x, y plus y is equal to 2. The next stage is x, y x, y plus y is equal to 2, making x the subject of the formula. What do? You actually do the following. X, y is equal to, take this over the other side. I beg your pardon there. Okay. We are making x the subject of the formula. We take x. X, y is equal to 2 minus y. 2 minus y. Then we want x to be on its own. Divide by y. Divide by y. So we have x on its own is equal to 2 minus y over y. So you got f x inverse is equal to 2 minus y over y. You replace whatever y is, you replace for x. So we have f inverse x is equal to 2 minus x over x. That is after replacing y for x. So you get your final answer as this one. They are quite actually very straightforward to work out the inverse functions. Let's go for another example, which I would like you to do by yourself. That's number 4. Fx is equal to 3x over 2 plus x. Okay. Would you like to try that one? Is that complex for you? Let's make it simpler for you. At your stage, let's simply have 7. Okay. Find that. The next question, 5. Fx is equal to x over 5. Work out that one. Also, the following. That's 6. Fx is equal to x over 2 plus 6. Work out that one as well. Number 7. Fx is equal to 3 bracket over x over 2 plus 4. Find the inverse. Okay? Find the inverse for this. Find Fx for all these.